Greetings from Team 7 of I Division. Now we'll take you through the course project that we were engaged in during this semester. The topic we chose was ball launcher. The name of our model is the Sphera launcher. Our team consists of 4 members: Varsha Chalageri, Prerna Naik, Himanshu Kumar and Sakshi Naik. We are really thankful to our guide Mrs. Radhika Amashi.
This is the problem definition of our model, which has been formed by combining all the constraints, functions and the objectives. It says to build an automatic ball launcher that will launch 6 sponge balls simultaneously one after the other. The balls are to be added manually. The machine so formed should be user-friendly, portable, compact and presentable. The machine should not weigh more than 3 kg and not exceed a volume of 2 cubic feet. The expenses for making it should be less than 3,000 rupees. The machine should perform the functions like storing, sensing and loading the balls. It should also indicate the state of the machine and when the balls have to be reloaded.
Function tree with clustering. The model has 7 functions: sense the ball, hold the ball, load the ball, store the ball, launch the ball, indication for reloading, and indication for state of the machine. We segregate these 7 functions accordingly, where storing, sensing, loading and holding the ball come under loading the ball. Launching the ball is a subunit in itself, and indication for reloading and state of the machine come under indication.
After the functions are segregated into different units, the subsystems formed are loading unit, launching unit and the indication unit.
Design 1. Design 1 works on rack and pinion mechanism, where the pinion is attached by a motor and a spring on either sides. This allows the pinion to move on the rack and launch the ball. The following components are same for all the designs: IR sensor to sense the ball, metal servo to push the ball, LED bulb to indicate the state of the machine, and a buzzer to indicate reloading. Design 2. Design 2 works on the principle of catapult mechanism. A basic catapult has 4 main parts: bucket, arm, tension source and base. Here, the ball holder being the bucket, 2 spokes being the arms, rubber bands as source of tension and hinges being the base. This design is similar to another type of catapult. Design 3. Design 3 is a combination of 2 mechanisms: pinball launching mechanism and rotating wheel mechanism. Here, 2 wheels are used. The wheel with less diameter is connected to a motor. This helps to increase the RPM of the wheel with bigger diameter. The stopper helps to increase the momentum of the launcher momentarily when compared to the speed of the wheel. Design 4. Design 4 is based on 2-wheel rotating mechanism. When the ball comes in contact with the 2 wheels, which are rotating in opposite direction with the help of a motor, the ball is launched.
Pub chart. Prioritized objectives. Operate for sponge balls. Launching of 1 ball at a time automatically. Portability. User-friendly. Compact. And presentable. When the designs were compared according to the prioritized objectives and design 2 being the datum, design 2 satisfied all the objectives effectively, may it be portability, user-friendly, compactness or presentability. It also scored the highest in the pub chart. Thus, we selected design 2 and named it as the Sphera launcher, where Sphera is ball in Latin.
We have seen that our model consists of 3 subsystems. One is for loading, one is for launching and another one is for indication. This design that we are seeing here now is for performing the function of launching. This is a motor. It is held in its position with the help of these 2 foam sheets. These foam sheets are attached to the base with the help of these L clamps with the help of nuts and bolts. This is an aluminium extension rod to which a bush is attached. Then there is an L-shaped clamp which is attached to this bush. This will perform the function of pulling the spokes for giving the launching effect. This design, which we are seeing now, is an integrated design for both loading and indication part. This is the loading tray which will hold the balls which need to be launched. Its capacity will be to hold 6 balls. This here is the indication part. It consists of the IR sensor and also there is a servo here. This tray will hold the balls just before launching. These two are the spokes which are attached to a hinge. These will perform the launching action. This part of the hinge is attached to the base with the help of nuts and bolts, while this part is attached to this T-shaped structure with the help of rubber band. This is how our model will look when all the subsystems are integrated. So this servo, it will have a barrier kind of thing which will block the balls from falling down. Okay, so this barrier will move up by 90 degree and stay in that position for some time. Again it will come back to the 0 degree position to block the balls. This timing will be based on how we have coded the Arduino. So once the barrier is lifted, one ball slides through this tray and falls into this holding tray. At the same time, this L clamp will pull the spokes till it loses contact with it. Now, because this hinge is wound with the help of rubber band around T-shaped structure, once this clamp loses contact with this, the T-spokes are launched forward and they exert a force on the ball which helps in its launching. This barrier will stay in the 0 degree position till this clamp completes one rotation because of the motor. This will go on till all the balls get empty. Then this IR sensor is used to detect the presence or absence of balls in the tray. These two are placed at a height keeping in mind to perform the functions which they are supposed to. So this is how our model will work.
This is the entire circuit of our model, combining both the launching and loading part of the circuit. The loading part of the circuit consists of the sensor to sense when the balls are to be reloaded, servo to launch the ball, and the buzzer to convey the indication for reloading. The launching part of the circuit comprises of the sensor to sense the ball, the DC motor to run the whole entire setup, and the LED. The circuit also has the relay that it uses as an operating switch, Arduino to set the time for the ball launch, and the breadboard to make all the connections required. The Simulink model of our project. These are the pictures of the flowchart and the state flow of our model. The detailed modulation will be explained at the end of the video. These are the components that are required to make our model. This table contains all the detailed specifications, quantity, in which part they are required, and the money it will cost.
Motor sizing. Weight of the sponge ball W is 50 grams. Length of the L-shaped aluminium rod L is 0.03 meter. Coefficient of friction between aluminium and steel mu is 0.45. Factor of safety is 1.5. Force is equal to mu into W. After substitution, force is 22.5 Newton. Torque is equal to force into length into factor of safety. After substitution, torque is 10.31 kg/cm. Battery sizing. Torque T is approximately 10 kg/cm. Speed N is approximately 13 rpm. Voltage V is 12 volts. Power is equal to 2 pi nt by 60. After substitution, power is 13.6135 watt. Power is equal to voltage into current. After substitution, current is equal to 1.3144 amperes. The size of the battery for 3 hours of usage is 3.9432 ampere hour. Functional specifications. Sense the ball. Balls should be sensed within the range of 0 to 4 cm. Hold the ball. PVC pipe of diameter 7 cm and length 12 cm. Loading the ball. Ball loading unit should move from 0 to 90 degrees. Store the ball. As the diameter of the ball is 7 cm and we are storing 6 balls, the length of the PVC pipe must be 45 cm at least. Launching the ball. Spokes should move between the angle 30 to 90 degrees. Indication for reloading. The buzzer should beep until the balls are reloaded. Indication for state of the machine. The LED glows red when the machine is on.
So this is the simulating model of our project, ball launcher, performing few operations using IR sensor, buzzer, servo and motor. The few operations which are needed to be performed for detection and sensing IR sensor by using buzzer for notification and for loading and launching using servo and motor. Coming to the flow chart of the simulating, here we have 3 states of motor on and on, symbolizing BZ is for buzzer, S is for servo, A and B are for motor, and IR is for IR sensor. Coming to first stat, which is off, BZ is 1, S is 90, A and B are 0, meaning BZ is initially on, servo is holding its position at 90 degree, and motor is initially turned off. If IR sensor detects the ball, means IR equals to 0, it shifts to the second state, which is motor on. There BZ equals to 0, S equals to 90, A equals to 0 and B equals to 1. Where BZ equals to 0 means initially buzzer was turned on, now it's turned off, servo is still holding its position at 90 degree and motor is turned on. Now these two sets, motor on and on, with a delay of 3 seconds, shifting takes place between these two stats for flipping of servo from 90 degree to 0 degree, and it occurs simultaneously for launching of ball, and ball drops from holding unit to launching unit and launches simultaneously with a delay of 3 seconds. In any case, if ball in the ball rack finishes, IR becomes 1, and from this state, either from motor on or off, the system can go to off from using this state or via this state.
Through this course, we learned about the engineering design process by developing a prototype of our project. This course has also enhanced our problem-solving abilities, our ability to think creatively, and analysis perception of looking into a problem. It also helped us to develop team working and communication skills. We would like to earnestly acknowledge the sincere efforts and valuable time given by our guide. Her valuable guidance and feedback has helped us in completing this project. We also acknowledge our principal for providing us the required infrastructure and facilities in the institute.